went to a bunch of different banks in town.
Okay.
Now, you know, the interest rates are really bad. I mean, you can barely make any money. But there were a few banks that I went to, and the first bank said that if I put my $1,000 in there, you might want to write some of this down.
I think I will.
Yeah, I'm gonna put $1,000 in there.
Okay.
They said they would offer me 2.5%
That's good.
on a 10-year CD. So I mean, they're going to give me 2.5%. Well, that would be pretty high actually. 2.5% annually. I got to keep it in there for 10 years. But the interest rate.
A CD, certificate of deposit.
Right. It's like a long-term savings account.
Beautiful.
So I'm wondering if I could write some kind of equation to represent that, and maybe even figure out how much I would have at the end of my 10 years.
Now, did they tell you how frequently they compound the interest?
Well, they're just going to compound once a year, so it's
Okay.
annual.
All right. So compounding, and compounding, as we all know, means they actually figure out the interest that you're owed and stick it into your account.
Oh yeah, they're going to pay me once a year.
Okay. All right. Well, here we go. Heck, your money's growing exponentially, isn't it? Isn't
Well,
it
I
like
hope so.
a percent increase? So if you start with 100% and every year you're going to earn 2.5% more, well, I think we could probably figure that out with $1,000 is what you start with. It's going to be 102.5%, so
Right.
written as a decimal, right? Am I doing that right?
That's right. It's 100% all the money I have this year plus an additional 2.5% every year. That's terrific.
Raised to the x. You want to know how much you're going to have in 10 years?
Well, actually, just start me out with 1 year. How much am I going to have at the end of 1 year?
Okay, even though you can't take it out.
No, but I mean, I could see how much my money's worth at
I'm
the end
with
of 1
it.
year.
Okay, so here we go. We can probably do this even without a calculator. What do you think?
I think times 1,000. I'm thinking you can move that decimal
I think
3
you can.
places over.
Boom, boom, boom. $1,025.
Okay, so I made $25.
You made $25 in a year.
Sure, my money went up by 2.5%, as
Yeah.
it says.
Yeah,
Okay,
I
great.
guess that makes sense. That was your interest.
That makes sense.
Do you know they have a fancy name for the what you actually earn in a year? Annual percent yield.
No.
So your APY was 2.5%, because that's what you actually earned.
That sounds good.
So you might be thinking, well, duh,
course.
my interest was 2.5, but you know what I'm going to say to Mr. Ross.
Well, go for it.
It depends on how often the bank compounds the
Absolutely.
interest.
So I could figure out how much I'm going to end up with at the end of 10 years. I could just stick in a 10 for x instead of that 1. So it'd be 1.025 to the 10th times 1,000. We don't have to do that now.
We all know
Let's
how
not
to
worry
do that.
about it. So why don't you erase that, and I'll tell you what happened when I went to the second. I go to a second bank. Let's call this bank
Number
2. Bank 2. That sounds good. Unbelievably, they also offered a 2.5% interest rate on a 10-year CD.
Fantastic.
But they told me they were going to compound quarterly. I guess that means they're going to pay me interest 4 times a year.
Absolutely.
I'm thinking, I don't even know if this makes any difference. It seems the same. It's the same interest rate, right?
I don't think so. Let's find out.
So why don't you write an equation to show me how they would compound
You're a
interest?
funny one, Ms. Ross.
Yes,
All
thank
right,
you.
so here we go. So it's the same thing. I'm starting with my $1,000. I'm going to break it down for you here. So you're going to multiply your $1,000 by your 100%. 100% in decimal land is 1. Okay? But now I'm going to take my interest. If I'm figuring out my interest quarterly, that means 4 times a year they're going to figure out the interest. So they're going to have to take the interest, 2.5%, and find a fourth of it. They're going to have to divide it by 4. So 2.5% is 0.025. They have to divide that by 4 to figure out how much interest to give me a fourth of the way through the year, and then 3 more times. And how many times are they going to do that per year? 4 times per year. So there you go.
So they're giving me a quarter of my interest, but they're giving it to me 4 times a year. So that's why, is that number on the bottom always going to be the same as that number upstairs? Is that a coincidence? Or?
No, that's always going to be the same.
No, all right.
Because you're dividing it by the number of times you're going to do it to find what fraction of the interest you're going to get. And this tells you how many times you're going to do it per year.
So let's see, after my first year, if I just put in a 1 for x,
Let's
it would
throw
be
that in there.
1,000 times 1 plus 0.025 over 4 to the fourth, because that's 4 times 1.
4.
So I have this in my calculator here, I get 1,025.23.5, let's call it 24. Because that's 1,025 plus an additional 24 cents?
You made more money.
Wow, where did that come from?
Well, I think if you think about it for a little bit, you can figure it out. You make interest on your interest in this scenario. A quarter of the year through the year, whatever I'm trying to say. What am I trying to say?
Quarter of the way through the year, that's perfect,
Quarter of
yes.
the way through the year, they figure out your interest and they put in your principal, so your principal's a little bigger. Then they find the interest on your principal that's a little bigger and give you interest that's a little more interest, and so on and so on and so on. So in the old scenario, you were just making interest off of your principal, off your $1,000. Now you're earning interest on your $1,000 plus a little interest. It's not all that exciting, but it changes your APY. Your APY now, that your annual percent yield is actually going to be a little more, 2.524%.
That actually went up by a little bit more.
It went up by a little more. You're earning a little more interest each year.
That doesn't make a whole lot of difference, but I suppose if the interest rate was a little bit higher, and if I left my money in there for more than a year, I mean, that could really add up to a difference.
And if you had more money to begin with.
Oh, that's right.
There you go.
All right, let's do one more. Why don't you erase that, Ms. Stewart?
Okay.
So, Ms. Stewart, of course, incredibly, I went to a third bank. I shop around.
Yeah,
that's just how I am. I'm choosing.
Good.
Same deal. I'm going to deposit $1,000. They incredibly offer 2.5% on a 10-year CD. But this time, they tell me that they're going to calculate their interest. They're going to compound their interest, I should say, monthly. So could I just stick in a 12 instead of at the bottom and on a 12x? All right,
You're pretty quick
well,
at
thank you
this,
very much.
Matt.
So why don't you do that?
Yeah, so monthly means I'm going to figure out the interest 12 times. So I'm going to divide the interest, or the bank divides the interest into 12 parts. And they do it 12 times per year. So that's going to be your equation. So if I want to figure out how much money I make after 1 year, it's going to be that. I think it's going to be a little more than what you earned quarterly.
In fact, it is. I get 1025.29 if I round off.
Okay, so, people might be snickering, thinking that's just a few pennies, but as you said before, if you have a bigger principal, if you leave your money in there, it's not anything to sneeze at. So don't let me catch you sneezing there, Mr. Haas.
Yeah, thanks.
So my APY for this interest compounded monthly is a little bigger.
And of course, if they were compounding daily, I would just put in 365 instead of
365.
And so forth. Every second, I mean, I could just put in like enormous numbers there.
You could.
Finally, Ms. Stewart, I went to the fourth bank. I'm losing track of how many banks I went to.
I think
it was
four.
a long day. So I went to the final bank, the fourth bank,
Okay.
and they said you deposit your $1,000, 2.5% interest on a 10-year CD, but they're going to compound continuously. That's like every single moment of every single day. I don't even. What does that even mean? I mean, it's crazy.
That means even more than every second of the day, they're going to be figuring out your interest and adding it to your account.
And I think there's actually a form of an exponential equation called continuous growth. And
there is, and we derived this in class. We're not going to go through the whole thing now. But what number do we end up getting when we compound interest more and more and more frequently?
that is E.
It's E. So the equation for your $1,000 is going to be $1,000 times E now represents our 100% plus the percent increase, right? Raised to the now in the exponent, that's where we have to put the actual interest, written as a decimal, 0.025 times x, where x is your time in years. Did I do that right, Mr. Haas?
That looks terrific. And sometimes students find this a little bit confusing, of course, right? When you put that growth rate as an exponent, you don't have to add the 1 plus
That's right.
thing.
The 1 plus is incorporated in the E, which you kind of can see when we derive it. As I said, we'll do that in class. For people in this class, they can come and ask us about that. But yeah, the 1 plus business is incorporated in that E. So it's just the interest rate itself.
And if I want to figure out how much money I have after 1 year, I just stick in a 1 for X, 1,000 times e to the 0.025, and I got it right here.
All right.
I have 1025.32. I think that's a couple more cents.
That is. Look at that.
That's terrific.
So your interest is $25.32. So your 2.5% really became 2.532 annual percent yield. You're actually earning 2.532% interest if you have a bank that's compounding continuously. That's such a cool number, that E. It shows up everywhere in nature. It shows up in exponential growth in bank. It's a powerful, fascinating number.
That's great. Thanks, Ms. Stewart.
Thank you, Mr. Haas.
So I have Lincoln Kelly with me, who's going to help me summarize this whole exponential growth and e-business. How you doing, Lincoln?
Doing good.
Now, you were taking a test, so I don't know if you kind of got all of this here.
Yeah.
But there's basically 2 forms of exponential functions that you need to know about. This one you've seen many times. So this is like saying I have a population, maybe of 5,000 people, and it is increasing at a rate of 6%. 6% growth. In other words, next year I'm going to have everybody I had this year, 100% plus an additional 6%. I think you're okay with that, right?
Yep.
Now, if it was continuous growth, like in the bank example, where interest was accumulating continuously, or it could be anything that's growing at a continuous rate. I don't know if you remember how to write that one. Were you with us for that one?
Yeah, you throw the E in there.
Yeah, that's the one with the E. So if I wanted to say that it was growing at a continuous rate of 6%, it would just be whatever my starting value is, E times E raised to the 0.06 times X. And again, X is like how much time is going by, whatever the units for time are. But notice when you use E, you don't need that extra little 1. So this is a 6% continuous growth. This is a 6% non-continuous growth. So how would I do 6% decay? In other words, something is going down by 6%. Let's say the population is 5,000 again, and it's decreasing by 6%. What would I have left? Just using the non-continuous form of the equation.
So we have 1 minus 0.06.
So that would be, I'm losing 6% of the population. I'm left with 94% every time interval, whatever that is. And to write that using the continuous form, it's a little bit different again. It's going to be E again, but it's going to be to the negative 0.06x. So that's, I hate to say the word memorize. I hate to say that, but that's something that you're going to try to have to remember. The continuous form looks a little bit different. Continuous growth rate of 0.06, remember there's no 1 in front of it. Continuous decay, in other words, population or whatever it is going down by 6%, you just stick a negative in front of it.
It makes sense because you can't subtract from 0.
And that's all there is to it. Is that, you can deal with those forms of the equation? Yeah.